So today in class you worked on a little bit of review. You went over finding the slope of a line that passes through 2 points. You were given the slope and the y-intercept, and you wrote the equation of a line using y equals mx plus b. The answers to the homework were gone over in class, and there are copies of them on the agenda from 212 and 213. You also practiced writing the equation of a line given a graph, which was from yesterday's lesson. And so today, now we're going to graph a line given the equation. So let's start with let's put today's date on it, 2/13, and go ahead and fill in your page number. And we're going to do some organizing at the end of the week just to make sure that we all have note pages in order and dates and page numbers all the same. And if we need any copies, we can get them off the web page or from Mrs. Sturgeon. So again, take notes from the video, write down any questions that you might have for class, and then I will help you and go through different examples tomorrow, and we will help each other while working in groups. So the steps for graphing a line given an equation. So from the equation, y equals mx plus b, because that's all we've been using thus far, you will find b and plot that as the point where it crosses the y-axis on the graph. Then you will find m from the equation, and you will do that as rise over run to get a second point. Now we only need 2 points to draw a line, so we'll use those 2 points to draw a line and label our line with the equation. So here's example number 1. We are going to graph the equation y equals negative 2x plus 3, and the value for b looks like a positive 3, and positive 3 on my graph is right here on the y-axis. And the slope from the equation is m equals negative 2, and because it's a whole number, we're going to put it over 1. So we have negative 2 over 1. And so I guess I got ahead of myself here where I plotted b already, and now I'm going to use the rise over run to plot my second point. And since it's a negative 2, we're actually going to go down 2 over 1, down 2 over 1, and every time we've done down 2 over 1, we can plot a point. Now, like I said, we only need 2 points, but I like to get a consistent graph and a really long line on my graph paper, so I like to just keep plotting points, as many as I can possibly fit on the graph, and then you would use your straight edge. Unfortunately, again, I don't have the capability to use a straight edge on here, but there's my line, and now all I have to do is label it y equals negative 2x plus 3. Let's try that again. Example number 2 is y equals 2/3 x plus 1. So finding b equals 1. Finding m equals 2 over 3. Remember, I'm always using it in the form y equals mx plus b. And so my m value is the constant rate of change. It's the coefficient with the x. And my b value is my constant. And so plotting b is at a positive 1 right here, and the slope being rise 2, run 3, rise 2, run 3, and maybe you don't want to plot a whole bunch of points on your graph. I have my 2 points here, and so I could just go ahead and connect those 2 points if I wanted to, up 2 over 3, and draw my line. And label it y equals 2/3 x plus 1. And example number 3. At any point in this video, if you wanted to pause me and go ahead and do the problem yourself and then play the video, you could check to see if our answers match up. And that's a good practice tool. So this equation, y equals negative 1/2 x, find b. Well, there's no b written. So I have to assume that it's just an imaginary plus 0, because we don't write plus zeros, just like we don't write coefficients of 1. So b equals 0, m is a negative 1/2, and now I'm going to plot b. So this graph is going to go through my origin at 0, 0. And I'm not rising because it's a negative 1/2. I'm actually falling 1 over 2. falling 1 over 2, falling 1 over 2. Now, what if I had run out of room over on this side of my graph? I can kind of go backwards and say, okay, instead of going down 1 over 2, I'm going to go up 1 and back 2. As long as you stay with the pattern of a line, because it's a constant rate that slope is rising or falling. And all of these end up still in a straight line. And that line is y equals negative 1/2 x, or 1/2 x plus 0, negative 1/2 x plus 0. Moving on to example number 4, another question of review. Given the linear graph at the right, write the equation of the line. So we start with finding the value of b. Then from b, we're going to count the rise over the run. And then we're going to use y equals mx plus b to write the linear equation of this particular line. So we have the 2 points marked for us, but if we didn't have them, we can just pick any 2 points on the line. So the value of b is right here at -4. And from there, I'm going to count the rise over run. So I'm going to go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3. So my slope is up 6 over 3. And I really need to start reducing my slopes. And so 6 over 3 is the same as 2 over 1, or m equals 2. So I have the value of b as -4. I have the rise over run as a +2. Now I'm going to use y equals mx plus b and put y equals 2x plus b, or -4, or plus a -4. Example number 5, same kind of thing. Review from 2 nights ago and in class. Given the linear graph at the right, write the equation of the line. So what is the value of b? Well, b is right here crossing the y-axis at +2. And we're counting rise over run, but I have a horizontal line. And if you recall from your 4 types of slope, m equals of a horizontal line 0, because there's no rise occurring. There is a run, but there's no rise. And so when I write my y equals for my linear equation, my y equals mx plus b, I have m is 0, which is 0x, plus b, which is 2. And I don't need to write the 0x. So I really have y equals a +2. And this was one of those special type of lines that I call special because it's just a line that crosses the y-axis at 2. So example number 6, new information. You can see that the review kind of got cut off here. We're using the happy hat again, and we're always using the happy hat because y equals mx plus b is called slope-intercept form. And basically, because it gives us a value for slope, the m, and a value for the y-intercept, the b. And so this question says, write the equation of a line with a slope of 3 and a y-intercept of -1. Well, I start off with y equals, I have my value for m, and I have a value for b. And so m is 3, give my x, plus b, but that's a -1. So I have y equals 3x minus 1. So let's review with example number 7, and remember, at any time you can pause the video, try the example on your own, play it or fast forward it to see if your answer matches with mine. So here we go. Write the equation of a line with a slope of -1/2 and a y-intercept of 5. Using slope-intercept form from my happy hat, I have y equals m, which is -1/2 x, plus b, which is 5. So the equation of this line is y equals -1/2 x plus 5. For example number 8, let's add one more step to what we have been doing so far. We just keep building off of everything on a daily basis and adding an extra step or going backwards and doing it the opposite way to get from a graph to an equation, or we start with an equation and we graph it. So right here we're going to write the equation of a line with a slope but they don't give us the slope. They give us the 2 points in order to find the slope. They do give us the y-intercept. So we know that the value for b is positive 2. Still going to use that happy hat, y equals mx plus b. But I do need to find the slope of this line by doing the slope formula. Remember, the Regents will give you the slope formula, but you really should know it and be able to apply it. So m equals, here's my x1, y1, and here's my x2, y2. So I have 4 minus 0 and 1 minus 0, which gives me 4 over 1. The slope of this line, these 2 points making a line, would give me a slope of positive 4. And I use y equals mx plus b to substitute that information. And so I have y equals m, which is 4, x plus b, which is 2. So now you have started with 2 points and a y-intercept and gotten to the equation y equals 4x plus 2.